For this video, I'll demonstrate how to use stata to conduct a correlational analysis and to conduct a bivariate linear regression analysis. To conduct these different analyses, we're going to use the growth and enhancement data for Montana students. And I've opened that data. You can see the message here. And we're going to browse that data for a little bit. And the variables that we're going to use for this demonstration are the 4th grade math criterion reference scores, 4th grade reading scores, and 4th grade science scores. And so I'm going to close this and I'm going to correlate those three variables. To do that, I need to go to Summaries, Summary and Descriptives, and Pairwise Correlations. And so then I'm going to select those variables. So I'm going to select 4th grade math, reading, and science. And then I'm going to click on print significance level for each entry. And then OK. And you can see from our output we have what's called a correlation matrix. So we have a matrix of variables and their correlations between one another. So in this case, the correlation between reading and math scores on the 4th grade CRT is 0.72 rounded off. And the correlation between 4th grade science and math scores is 0.69, almost 0.70. So these are fairly substantial correlations when considering 0.80 would be considered, and above would be considered, a large correlation. The results underneath each one of the correlation coefficients represents the significance of those correlations. So you can see that these are highly significant. In other words, p is less than 0.0001. Now, it's often the case that we like to look at two variables that are closely related to see if we can even find out more information about how they relate to one another. So in this case, I want to demonstrate how we can use reading to predict or explain a student's performance in science. And one way we can do that is to conduct a linear regression analysis. But before I do that, I'm going to graph the relationship between the science and the science and the reading scores. And so I'm going to use a scatter plot to do that. And the variable that I'm predicting, my independent variable, is science. And the variable that I'm going to use to explain or predict science is reading. And so if I submit, then I will get this scatter plot. And you can see it's a fairly linear relationships. That's one of the assumptions to conducting a correlational analysis or a regression analysis, that there is a linear relationship between the two variables that we're investigating. And you can see that low reading scores are associated with low science scores, and that high science scores are associated with high reading scores. So that's what gives this a linear relationship. And we can see that most of our data is really stacked up in the upper end of the distribution for both variables. And in previous videos, when we produced the histograms, we could see the data was negatively skewed in the sense that most of the data was falling in the upper end of the distributions for each of those variables. So I can go ahead and save that. Scatter plot for future reference. Now, To conduct a linear regression, I can go to Statistics, Linear Models, and Linear Regression. And in this case, my dependent variable, the variable I'm predicting or want to explain, is science. And my independent variable will be reading. Now, the other thing I want to do is under reporting, I want to also specify standardized beta coefficients because I want to be able to know what my beta coefficient is in terms of a mean of 0 and a standard deviation of 1. Now that's not so important now because we have only one beta coefficient to look at. But in future analysis, when you're doing multiple regression, you may have several beta coefficients that you want to compare. And when they're standardized, all the beta coefficients, regardless of the measurement scale the variable's on, is a standardized comparison. So I'm going to go OK. And so we can see the results of our regression analysis. Now we have a lot of information on this page. And probably the first thing we want to look at is the R-square. In other words, how much is this science scores, or the science scores, being explained by reading? So we can see that to interpret this R-square, 46% of the variability in science scores is due to a student's reading ability. And this is a significant result. In other words, that relationship is significant. Being that this is linear regression, if we were to take the square root of this, we would find that it was 0.679. In other words, R square is this value squared, and that's the value we get here. Now, this is just a bivariate linear regression. That's not the case with multiple regression. But with linear regression, when you're just having two variables, R square is directly related to the correlation coefficient. Now, the other thing we can look at is our coefficient table. This is the constant, and this is our unstandardized beta coefficient. This is a standard error, and what this tells us is that this coefficient is significant in terms of predicting or explaining variability in science achievement. This is the standardized beta coefficient. So this coefficient is standardized in the sense that it's based or scaled on a mean of 0 and a standard deviation of 1. As a result of our regression analysis, these results that we've obtained, we can use these results to form a regression equation. In other words, we can use these results to predict what students who read at a certain level or who obtain a certain score on the criterion referenced reading test would likely to score on the science test. So in this case, our regression equation is the predicted value of y is equal to the constant plus the beta coefficient times some value of x, or some value of the reading score. So in this case, let's say we want to predict what the science achievement score would be for a student who earned a score of 286 on the reading test. So our regression equation would be 81.16. I get that from the constant, plus 0.655, that's the beta coefficient, times 286, which is the score for the first student in the first record. And when I calculate this, my calculation comes out to be 268.49. So in other words, a student who scores 286 on the criterion referenced reading test is likely to score 268.49 or about 268.49 on the science test. I hope this explanation of correlation and linear regression has helped you to understand these concepts much better. Please let me know if you have further questions.